Okay, our next example of producer surplus and consumer surplus. In this case, we're given a supply function and a demand function, but we're asked an extra thing. In this case, we're asked to sketch the regions of producer and consumer surplus. And a lot of times you are required to do that. I'm not really all that particular about what your graphs look like, but it is going to be important for them to be the same shapes. So either way, in this case, we want to start off by finding the equilibrium point. The equilibrium point is going to give us a good point to put on our graph. It's going to allow us to separate producer and consumer surplus, as we'll see in just a second. So step one, same as before, is to find that equilibrium point. And in this case, it's a little bit challenging because it's quadratic and there's a ton of decimals. Let's go for it. So we're going to set our supply function equal to our demand function. Now, because these are quadratics, we have those x squareds, we know that we want to get everything to one side with 0 on the other. So I'm going to make that happen by adding 0.001 x squared. And by subtracting 250, so that's minus 150 equals 0. So that 0 on the right side is good. That's what we wanted to happen. And now our goal is to factor this thing. So it turns out that this actually factors quite nicely. So I'm going to factor it using product sum. And I'm going to show you a good way to approach that. But if you're really uncomfortable with that, you could use the quadratic formula. So the first thing that I'm going to do is I'm going to get rid of the decimals. And I see that this 0.0016 has 4 values after the decimal point, and the 0.02 has 2 values. I want to get rid of all of them, so I'm going to multiply by the multiple of 10 that allows me to do that. So option 1, get rid of decimals by multiplying by a multiple of 10. Then factor. And your option 2 is, if you'd rather, you can just use the quadratic formula. And I'll remind you that's the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So these are our 2 options. I'm going to go with option 1. So I want to get rid of those decimals. So I'm going to multiply both sides of this equation by 1 with 1, 2, 3, 4 by 10,000, those 4 zeros, so that I can move this 1, 2, 3, 4 places to the right, the decimal. So what I'll have left when I do that, when I'm multiplying both sides by 10,000, is 16x squared. I'm also moving this decimal 4 places to the right, 1, 2, 3, 4, which means I'm going to have a 200 in the middle here, plus 200x, and then minus 150. I've also got to move the decimal 4 places to the right here, minus 150, which means I have 1, 2, 3, 4 extra zeros, and it becomes 1,500,000. You might be looking at this polynomial and thinking, ew, I would much rather use the quadratic formula. Totally fine. You're welcome to. It depends on how comfortable you are with factoring. I personally am more comfortable with factoring than I am with the quadratic formula. So now I'm going to factor the greatest common factor out of this thing, which is 8. So I'm going to have 8 times 2x squared plus 25x minus 187,500 equals 0. Now, I know that this is going to be 8 times 2x and an x here, and I need for these numbers to multiply to give me that 187,500 and for the 25 to work out in the middle. And it turns out that the values that make this happen are 625 and 300. Again, you might be like, how on earth did you find those values? That's gross. 187,500 is really big. That's fine. You can use the quadratic formula. That said, when you're using the quadratic formula, you can use it from any step. You can use it from that first step where I had those decimals. You can use it from the second step when I had the 16x squared. You can use it after you factored out the 8 when you have 2x squared. And it might actually be easier for you to use the quadratic formula from here. So you might notice that this is going to give me two values. This gives me x is equal to negative 625 over 2, and x is equal to 300. Which one do I take? Well, we know that this x is representing a number of units. It's my equilibrium number of units. Clearly, a number of units can't be negative. So negative 625 over 2 does not make sense in the context of the problem. We want to keep the positive one. So I can say then that x sub e is equal to 300. And now I want to find my equilibrium price. So this is equilibrium units. So my equilibrium price, I can plug that equilibrium units into whichever one of the functions that I want. I'm going to go ahead and plug it into the demand function. Yeah, the demand function. So in other words, my P sub E is going to equal to negative 0.001 times 300 squared plus 250, which gives me a negative 90 plus 250, which will give me a 160. So that is my equilibrium price. So x sub e, y sub e, by y sub e meaning p sub e, x sub e, p sub e is equal to 300, 160. So that is going to be useful for calculating both producer and consumer surplus, but also for graphing this thing. So I'm just going to remind us that our supply function here was 0.0006 x squared plus 0.02x plus 100. And our demand function was negative 0.001 x squared plus 250. Okay, so a rough graph is going to be okay, but there are a few things that are quite important. I need to find the y-intercepts. In other words, I need to find what happens when x equals 0, so I know what's going on over here, because I need that left bound, and I have my equilibrium point, so I already know what the right bound's going to look like. I need to know the shape. These are both quadratic, they are both parabolas. The 0.0006 is positive, so that's a happy parabola. The negative 0.001x squared, that is a negative, so that's a sad parabola. So to graph, first find y-intercepts. So for P sub S, for my supply function, that is 0 plus 0 plus 100 is equal to 100. So in other words, when I plugged in 0, I got 100. So what that means is my y-intercept is 0, 100. And for my demand function, I get 0 plus 250, which gives me a 250. So my y-intercept here is 0 to 50. And so now I can graph this. And the scale that I'm going to use is, well, my equilibrium point is 300, 160. My y-intercepts are like 100, 250. So I'm going to go up by like 50s. So I'll have 50, 100, 150, 200, 250, 300. And then we'll do the same thing. 50, 100, 150, 200, 250, 300. And so I'm going to start by graphing my y-intercepts and my equilibrium point. My equilibrium point is 300, 160. So that is about right here, my beautiful straight line. So my equilibrium point is there. I know I'm gonna need to draw that horizontal line to separate producer surplus from consumer surplus. So I'm just gonna straight up do that to start. And then my y-intercept for my supply function is 0, 100. Now my supply function was a happy parabola, so I'm just gonna draw that. Notice I wasn't perfect. I wasn't like, I know exactly where it's going to start curving up. I didn't think about that. I just drew a happy parabola. Same thing with my demand function. My demand function, that y-intercept is 0 to 50. And I know it's a sad parabola. So that's my demand function, and that's my supply function. Now think about it, see if you remember which is on top and which is on bottom. Consumer surplus on top or producer surplus on top? I know that my demand function is the function that represents consumers, so that means I have my consumer surplus on top. And my supply function is my function that represents producers, so I have my producer surplus on the bottom. So there we've graphed the region and we have sketched the regions of producer and consumer surplus. Now we're going to solve for both. So you might be asking yourself, oh my gosh, I have to graph. What are shapes I need to know? You really don't need to know that many. Knowing what parabolas look like and recognizing equations that represent parabolas is going to be important, straight lines, and also rational functions. And we'll do a question in the next video where we have a rational function that we have to graph. So our next step now is we want to calculate consumer and producer surplus. So that's my step 2. I'm going to go up a little bit so I can see those functions. So my consumer surplus is equal to 0 to the x value of my equilibrium point of my demand function minus the y value of my equilibrium point, which is 160 dx. There we go. So here we have 0 to 300 of negative 0.001 x squared plus 90 dx. And we take our antiderivatives and get negative 0.001 over 3. So that's 1 over 3,000. Negative 1 over 3,000. X cubed plus 90x between 0 and 300. So notice I just simplified that, but this negative 1 over 3,000 is the same thing as negative 0.001 over 3. Now I plug in and I get negative 1 over 3,000 times 300 cubed plus 90 times 300 minus 0 plus 0, which gives me negative 9,000 plus 27,000 for a final answer of 18,000 consumer surplus. It's money, so I put my dollar sign. There we go. So in this case, it was just taking a simple antiderivative. We really just needed to remember our formula, the demand function minus that equilibrium price. Now for my producer surplus, we have the same bounds as 0 to the equilibrium units. Now though, I'm starting with my equilibrium price and I am subtracting my supply function, which was 0.0006 x squared plus 0.02x plus 100. Again, don't forget that that minus sign is getting distributed to the inside. The minus gets distributed to everything. Don't forget those parentheses that tell you to do that. Or just immediately distribute the minus sign. So then I get that this is 0 to 300 of 160 minus 0.0006x squared minus 0.02x minus 100, 0 to 300 of 60 minus 0.00, I'm tired of writing these decimals, I'm sure you are too, minus 0.02x dx. Now we find the antiderivative, 60x minus 0.0006 over 3. So that is going to be 6 over 30,000, which is 1 over 5,000. 1 over 5,000, I hope I did that right, x squared, minus 0.02 over 2. So that is 2 over 200, that's 1 over 100, x squared. And I'm sorry, that was supposed to be a cubed here. We were dividing by 3. So again, just so that you can make sure that you understand where these are coming from, this is 0.0006 over 3, which you can plug into your calculator to see it gives you that 1 over 5,000. And this is 0.02 over 2. Now I'm evaluating between 0 and 300. So that's 60 times 300 minus 1 over 5,000 times 300 cubed minus 1 over 100 times 300 squared minus 0 minus 0 minus 0. And this will give us a final value of 11,700. Sorry, I didn't feel like doing that part in my head. 11,700, producer surplus. So in other words, that is like extra money that the producer got that they would have been willing to go without. That 18,000, that is money that the consumer saved that they would have been willing to pay. All right, so that's it for this question. In the next video, like I said, we'll do a rational function, and then that will be all.